In this video, we're adding flicker-free ambient light inside the passenger coaches.
Hello and welcome to a video tutorial in which we will assemble interior lights into passenger coaches or passenger cars. Well, you might think, why spend a video about this, since the manufacturers and also third-party manufacturers has ready-made LED strips for this purpose. It's just snap and plug and play, isn't it? No, actually, experience has shown that it's not just plug and play. It's a kind of lengthy assembly, even with ready-made products, and also the ready-made products are lacking in performance. You know, like flickering lights or all kind of problems. So my friend here, Magnus, yeah, he's been researching both on the internet and made his own investigations on how we can make illumination inside passenger cars which is low cost, 105% flicker free and easy to assemble. And I saw his video on this topic and I thought, hey, we should bring this out to everyone. I asked him, can we make a Märklin Sweden version of your video? And he said, yeah, sure, absolutely. I will come over to you and show you the steps I do when assembling this illumination. And so what you will see here is the lights coming into my first set of passenger cars.
The passenger cars we're going to work with is German state railroad company Express Train. This set of passenger cars is a Märklin item 42751. Removing the gangways will on most modern passenger cars separate the body from the underframe. Once separated, move the interior to the underframe. Most often a car body will look symmetric, but can only be assembled one way. Therefore it's a good idea to make a mark with a pen, so you know which ends to pair together. The interior light will be powered from the electricity in the rails. To make this possible, we're using a spring contact. This spring contact here is manufactured by Märklin and comes in a set of 5 pieces. It has item number 72050. Now, if you have a 3-rail system, like I have, then the other pole will be picked up using a pickup shoe. To simplify wiring, it would be easier to mount both the pickup shoe and this contact spring in the same bogie, but it's not. It's better to keep them separated in each bogie. Then the setup will look more like a 2-rail system, which instead has a contact spring in each bogie. Now, these contact springs are designed to fit every passenger coach in the entire assortment, so in most cases they need cutting, otherwise it's a risk for short-circuiting with the conductive couplings. I also typically remove the provided wire because I think it's too thick and unflexible. When soldering such thin cables with thin plates, I lower the temperature on my soldering iron down to 350 degrees Celsius. The cables I will be using throughout the entire installation here is a AVG36 cable, high flex PTFE isolated, at a total diameter of 0.5 mm. Remove the isolation and then tin the cable end and solder it in place onto the contact spring. A good solder joint is glossy, a poor one is bubbly, which means too much heat has been used. Now feed the cable coming from the spring contact through the hole under the rear wheel pair in the bogie, and then either snap the spring in place or glue it in place like I do here, because there were no matching spring contact fittings. And on the other side we're pressing the slider in place. If you're working with a 2-rail system, then you're gluing or snapping in another contact spring here. Now feed the wire coming from the spring contact in the other bogie into the hole here and up into the passenger car. In a 3-rail system you typically want conductive couplings. That's because you don't want a slider under every car because it makes a lot of noise. This is a 2-pole magnetic coupling from Hog, which just snaps together with magnetic force. This is basically a Fleischmann Profi-koppel with a kind of wire contact on each side. This is also a 2-pole couple. I will be using the single pole coupling from Märklin. It's the Märklin short couplings. This type of coupling is available in a 20 pack that has item number E115737.20. We will first tin the tip of the copper part here. In this situation it's good with a helping hand. The color of the cable to this one is black. The ground coming from the spring contact is brown. In some passenger coaches the neem pockets are kind of tight, so sometimes they even crack when you put these conductive couplings in. So what I'm doing is I'm just grinding this down so it gets a bit thinner surface, and then I cut one of the snap fittings. That is enough. That way you don't risk the neem pocket. So then I feed in the cable through the neem pocket first, and then I insert the coupling like that. Yeah. Then I feed that wire, I pass it on through the boogie, same hole as the brown cable coming from the spring contact. And then I want to fix those cables to the car under frame. But first, move everything so you make sure to have enough cables so it does not prevent moving, because that will make the car derailing in the first curve. So with a half a drop of fast set glue, the cables gets fixed to the underframe. The reason for not routing the cable inside the car is because the clearance inside the car is most often very limited. An easy thing to do here would be to connect both of the conductive couplings to this copper surface of the slider, but experience has shown that it's a big risk to solder here because the heat from the iron can damage both the slider and the boogie. So we're routing the cables from both of the conductive couplings into the car. Experience has also shown that the best place to hide the electronics is in the toilet. To route the cables there, it's very handy to have a drill set like this on hand. So here's the toilet, and here's where the cables come up. So what we need to do is a hole through this wall here. So I'm taking a 2.5mm drill and make that hole. It's big enough so I can feed the cables through. With the cables on the toilet we can start assembling the electronic components necessary. This is a bridge rectifier. It has 4 terminals. The terminal I'm marking here is the plus output. We also need a capacitor. For this application we're using a 220 microfarad and 25 volt. Make sure to identify the minus side. Fold the terminals like this, and then around the pins of the bridge rectifier. Make sure now that the minus and the plus matches the minus and the plus on the capacitor. And let's solder the components together. Now, as you might have noticed, the interior of this car is very moderately detailed, so there's plenty of space on the toilet. In some other cars it might not be, and then there might be a possibility that you need to put the capacitor in the roof instead, and not both the capacitor and the bridge rectifier on the toilet. So that's something you can keep in mind. Here I'm connecting the black cables together, coming from the conductive couplings and the slider, with the input on the bridge rectifier. I'm also connecting the brown cable, which brings the ground connection to the wheels. push the components into the toilet, and then we're ready to prepare the illumination part. I'm buying these rolls on Wish. They're not more than 25 euros or $25 each, and contains at least 9 or 10 meters, so the price for the illumination required for a car is about €1 or $1. Make sure though to buy warm white and that it's a 12-volt strip. There are markings on the LED strip where to cut. These LED strips also comes with a self-adhesive tape on the back side. Now this tape is not so very good, so what we need to do is to secure it with a few drops of fast set glue in the roof. What we also need to do is reduce the brightness. This is achieved by using two 10 kilo ohm resistors in series with the LED strip. So I soldered them directly onto the connections on the LED strip, and then the brown ground cable to the minus and the black plus cable coming from the bridge rectifier output plus terminal. Then I take a measurement so I can see approximately where I should place it to get an even distribution of the light inside the car. I remove the protective tape and then I push it into the roof of the car body. I twine the cables coming from the LED strip and fix it with a small piece of tape, so it's aligned with the white toilet window and thereby invisible. Well, adding illumination in cars like this forces you to also add some passengers, otherwise the cars look very, very empty. So with this set, I picked this one up from Noch. It has item number 15250 and contains 12 happy passengers. And I fixed them to the seats using fast set glue. Alright, so now we're almost done with our car here. It's just to fit the passengers and then snap the car back together again and push in those gangways, and we're done. The luggage car often goes last in a set like this, and therefore we'll have red trailing lights mounted on this. This is a 0402 LED with the pre-soldered copper wires. You can buy these in packs of 10 or 100 or 1000 if you like on the eBay. And I was thinking to route the cables into the assembly hole for the leather here. On some coaches or cars you need to drill new holes for the copper wires, but they are so thin so they sneak through the hole of that leather assembly. And then a quarter drop of fast set glue and push the LED into that. Now I'm coupling these two LEDs in series with each other and then to the resistors. And just paint some matching color. In this application it's olive green to cover the cables. Alright, so this is what it looks like when we put it onto the tracks. And let's now check. Now I lift it, and the car actually is lit for about 10 to 12 seconds with nice looking lights before the capacitor energy has gone out. So then I just put it back on the track and we're done. So here's our set in, I would say, average background illumination. So you see that there is illumination inside of the car, and you see, of course, the trailing lights. If we dim the lights down totally, this is no ambient light, then we have this look. If you like brighter light, then reduce the value of the resistors. If you want even more dim, then you increase.
Alright, I hope you liked the tutorial. If you did, please help others to find this video by giving it a thumbs up. If you have any questions at all about the methods or materials presented here in the video, please post them in the comment field below and I'll try to respond to that as soon as possible. Did you know that this channel is made possible because a few viewers are supporting the channel? So if you feel that this channel is helping you with your hobby, get over to Patreon, set up a support account there, or make a one-off donation via the PayPal dialog found in the video description below. Again, thank you very much for watching this video. If you like to see more, please subscribe and enable the little bell, and you will get a notification once the next video gets published. Until that happens, see you.